Good morning, good afternoon, good evening, based on where you are. Thank you very much for being here. And good afternoon, Philippe, as you are on the CET time zone. We are going to wait a little bit. The number of persons is quickly rising up. But otherwise, very excited to be here. How are you, Philippe?
Yes, very good, thanks. And definitely, very excited to talk about this recent development in this red team and pentest engagement. So very cool to be here.
Very interesting topic indeed. This is for us something that we spoke a lot about together, as how to deploy the team and how to have everyone having the right skill sets for all of this. But it's historically been our signature, I would say. This is kind of where you're coming from, right?
Yeah, exactly. So do we wait a little bit until people join?
I think we can. I think we can wait a couple of minutes just to make sure that everyone is here. We know how those late meetings happen. Sometimes you jump from one meeting to the next. So having a couple of minutes before we start is always helpful for everyone.
And, this is a topic, if for the people who know me directly, that is I'm very much fond of. I'll tell you precisely why. But there's plenty of content here that we can't go in depth. So there's a lot of opportunity to actually talk to everyone. We'll be at Mobile World Congress, and that's a good opportunity to go in depth, but also definitely get in touch with Pierre, with me, with Yves, with Vikas, with Elia, with everyone in the team. There's really plenty to discuss, and which are very often very specific to your organization. So that's the interesting things coming up.
And what are we going to talk about? We're going to talk about kind of a consolidation of learnings about red team assessment toward telecom security infrastructure. Telecom infrastructure, I apologize. We've been doing red team assessment since the very beginnings. It's the background of Philippe on how to get into a target. And the complexity of telecom infrastructure has made it both interesting and highly complex. And what we are seeing from lately what's happening in the world is that there is a lot of interest as to how do we connect those different planes, those different domains, and the idea was to share, and so some of this research has been shared already. Shared a little bit what we've gone through in the last couple of years, I would say, in terms of pinging here and there the research and the interest. But for this, I will leave Philippe to share how we approached it and the learnings from it all. Obviously, one quick logistics topic. If you have any questions, use the chat. We have our fantastic Amin behind the scene helping us in getting your questions at the right time, at the right moment. So ask away, comment. We'll feed them nicely into the webinar. Philippe, I'll leave you to maybe to start and discuss this physical to 5G core compromise topic.
Excellent, thank you, Pierre. So yeah, P1 security has been delivering since day one. So now that starts to be something like 16 years ago or more. These penetration testing and red teaming assessment. And red team is very specific in the way that it's a wide target on typically organization or big part of the infrastructure. So here I want to tell you about our recent mission in that domain, which encompass, of course, the new network which have been deployed, which are 5G and specifically 5G standalone networks, but also encompassing new areas such as the physical domain. There's plenty of new perimeters that are popping up. One, for example, being eSIM, another one being the NTN, the satellite exposure and attack surface. These are the stuff which are typically a focus of upcoming red teams, because it's very often on these where we find new vulnerabilities, new type of vulnerabilities, but also some where the customer doesn't really know what exists as an attack surface. So here I'm going to tell you first about the current status of the focus of our customers. Of course, we have two big kind of network. The legacy being a 4G network supporting a 5G radio antennas, so that's a 5G non-standalone or 5G NSA. And there's the new ones, new deployment, the ones that start to go in production or are in production, which are the 5G standalone, which means that you have a complete new 5G core running on even more standardized protocols, so HTTP2. And that's the bulk, the major focus right now from the customer. We want either to test if the current working infrastructure, the production infrastructure is well secured, or if they sometimes want to do it just before going to production. And here, what we can see is the red teaming. You take the whole organization as a target, or sometimes just the OT part, the operational technology, and you're going to say, in this, where is the soft spot? And regardless of what is the chaining of vulnerable component, the goal is to take ownership of the infrastructure. Sadly, we've seen many APTs being caught doing exactly that. So these advanced persistent threats are basically nationwide groups, most of the time emanating from intelligence or ministries of defense, who are attacking other countries. And they are attacking other countries with very precise target, basically compromising infrastructure in order to know who is under lawful intercept, be able to trace and identify people, be able to compromise strategic communication or economic conversation. And very often, the bleeding edge technology or the big legacy are the places where these APTs find their soft spot to get into the operator. So problem we have in 5G, and we've seen, is that there's a big tendency to be vulnerable due to gaps in the security, because vendors are developing on security specification, which are with big releases. So we'll have a release 16, release 19, and these come with a set of technology which will provide security benefits. So for example, when we talk about 4G, the technology was mostly virtualized Linux. But when we talk about 5G, and when what is brought by 5G SA typically is more Kubernetes cluster and containers. And with these new technologies come with a lot of security improvements, which are tied to the technology. But when this technology is deployed, then there's a kind of wait for the next generation to benefit from all the new technology and all the new protections that it brings. And what we can see here is that these doesn't come out of nowhere. It's because the vendors, they have a focus. It's to keep the network reliable, to have continuity. So they have a really tough job to make sure the network doesn't crash, is able to cope with traffic. And so that means that in the CIA confidentiality, integrity, availability kind of focus, the first focus is on availability, and then on integrity and on confidentiality. So here, this focus means that the downstream, the consequence, is that we have a biased approach to security. Now, the operators kind of just deploy these technology from the vendor. And they have to cope with the complexity of their network, with integrating with the legacy. So that means that they have a very low margin or wiggle room to insert security controls. And typically, this is the case, for example, when you have a 5G core, it's difficult to, for example, insert EDR because the vendors of the telecom core and RAN did not really test and could not really test with a wide variety of solution, EDR solutions that exist. Also, what is quite important is that there's a lot of gaps, meaning that if you look at the specification, there's going to be a false sense of conformity. That means that you'll think that your network is only running on HTTP2 and that any pen tester can do the work. Whereas what we see is that there's a lot of extensions, a lot of proprietary behaviors, and for example, ways to use HTTP2 in a very specific way, with specific publish subscribe, with specific header, which are absolutely not seen anywhere else. Finally, what we see is that there's a lot of gaps in the representation, meaning having an exhaustive representation is actually very different. And that's our own, that's the representation that we come up with. It's very different from actually what is in the spec, because the spec, even if they talk about, let's say, the global core of the 5G network, they are going to see it from a service perspective or from a roaming perspective. And each of these perspectives come with a bias. So that means that if you look at it from what should be from the theory, it's absolutely not what you're going to get during a real-world 5G red team. And that's the power of red teaming, is that it's a big reality check. You see the reality. And for us, it has been super important since day one, because it enables to give the customer unbiased view on their security. We can provably and demonstrably show how we compromise the core, how we get access to the subscriber or customer keys or identification or data. And there's no place to say, yes, but this is maybe not so important. Here, basically, if there's a compromise, there's a problem. Now, what we see is that in the last few years of 5G deployment, there's been a lot of security improvement coming from the specification, especially with subscriber security, with the fact that the subscribers are more protected when they roam to other networks. They are more protected on the radio also. But what we see is that the specification also came with a lot of focus on making things interoperable and compatible with the legacy. And that means that some insecure configuration, such as null encryption, lack of mTLS, etc., are not advised, but are still possible. We see that then, since it's a code to spec, the development from the vendor is done according to the specification. If things are allowed to be in an insecure way, they will end up in an insecure way on the core network, on the radio network, etc. And
Philippe?
That's a real big problem. Yeah, Pierre.
There is a couple of questions. You mentioned mTLS right now, and Alexander and Boguslo were wondering on, our experience in terms of adoption of mTLS for standalone 5G. There is the first question on how wide do we see the adoption of mTLS, and the second question on having 002 and release 18 improvements again on mTLS.
Yes. So thank you for this question. Definitely, what we see is that any network which strongly implements 002 is going to be by a huge margin more secure. Now, the question is that sometimes the 002 is going to be just a check, and actually the generation how a certain network function can say my identity is this is an upstream notion to mTLS. So if you have mTLS, but mTLS comes with everyone has the same certificate, it's pretty much as if you didn't have mTLS. If the 002 is coming with the same kind of identity for all network function, same thing. We have basically a problem because it's kind of easy to get to imitate any kind of network function. So once again, it's really where shine red teaming and penetration testing is that it will help you differentiate between what security measure was just enabled but in an insecure manner, just to get 002 check and actually it's not providing any more security, or if it was a real good implementation. And real good implementation means source of trust, meaning that you have some kind of registry or certificate authority which enable dynamic enrollment of network function, etc., etc., etc. So here there's really way too much space for full sense of security, or it's also called sometimes snake oil security, meaning that you can use keywords but still have an insecure network. And that's where we really want people to focus, to not only believe into what is being advertised in security compliance questionnaire, for example. I hope that answer basically the question. What we see also is that there are sometimes some big aspect related to the capacity of the network. And we've seen behavior of network vary between a network under load, so typically in production, and a network in a testbed. So that's why penetration testing on your testbed is a very good idea. Definitely, that should be a mandatory step in pre-release. But that doesn't save you from doing a post-deployment red teaming on the overall operational technology. And that's really something super important. So here and I see other question. It's quite important to say that we are only at the beginning of this real-world deployment, because when you talk about, for example, these mTLS, these HTTP2 deployment of the 5G core, now what's coming up is this 5G roaming. And what we see is that the typical customers, they are starting with a pentest on a very limited perimeter, let's say 5G roaming, and then they go for the global red team where all the perimeters are integrated. What's important to see is that we're answering two different kinds of questions. And here we see that we are not yet at maturity on 5G, HTTP2, SBI kind of communication. And already, as was asked, we see already some 5G roaming activation that are starting to happen. At least, basically, some operators are going there. But we see a race, and it's super hard to say that the maturity is there yet to be confident about the security of the HTTP2 based 5G roaming. So, and once again, here I could go in depth. There's really interesting questions in terms of type of deployment of these. Do we go with a central SCP, etc., etc.? There's plenty of things. So for these, for more in-depth questions, we'll be able to do basically separate session and maybe even a webinar to go more in depth into the technicalities of this. But let's go on to the next ones. So this accumulation of legacy, what we see is that it's a huge difference between what should be in verticals and silos and well isolated, and actually what we end up attacking when we do a red team, which is typically a huge accumulation and merging of OT infrastructure. Meaning that you have in a single view all the systems that deal with the physical DWDM optical network, with the services such as IMS, with the management, what is called OSS or OAM, Operation and Administration and Maintenance, with the actual 5G core. And this typically will show gaps which are not really only technological, but which are very often organizational. And very often the red team is interesting because it shows a problem where you're going to jump between a lot of different systems to establish what is called a kill chain. A kill chain is the capability to go from one vulnerability to another, to progress in the network, and typically to discover and attack the network using things which are completely disconnected in terms of ownership within the operator. And typically that's going to be discovering information through DNS, which leaks information, being able to compromise some systems through the OEM network, then being able to jump onto either the lawful intercept or being able to jump onto new bleeding edge things such as orchestrators. And what's important here is also to understand that not all interfaces are well understood, because some are specified, but some are completely proprietary. And what we see is that we kind of have kill chains, so a sequence of vulnerabilities, which are in very much varied domain. And sometimes it's very shocking to the customer to see that we jump from a very legacy part to a 5G standalone part of the network to the OEM without much constraint. Now, in terms of this red team, Pierre, you wanted to interject here.
Yes, for me, one of the key realities as a reminder for red teams is we are seeing in 2025, all the threat reports that you can see. There is actually a new one who just came out that I saw. I will share the link later on, but we are seeing a lot of APT attacks, and those APT attacks are exploiting very wide attack surface. That reality of having an extremely wide attack surface brings a dual need for operators. We need to go in depth into network functions, equipments, vendors, and this is a clear necessity. But now what we are seeing is they coming from the roaming, so that would be liminal penta. They coming from the roaming, they stay a little bit, they hide, and then they move either laterally or they compromise, they social engineer. They are exploiting multiple TTPs into multiple domains, exploiting multiple attack surfaces. So that reality is MNOs now are coming to us, and that's why we're having more and more insights to share with you guys, because they come to us saying we have to do both exercises. We want to go wide, understand how all those attack surfaces connect, and we have to go deep because they are going extremely deep. And when you look at the understanding, the telecom understanding for Sol Typhoon on how to compromise the HSS, on how there is a lot that they are exploiting, and the multiplicity of skill sets is very difficult to manage. Yeah. So yes, so that's why I think going to how do we approach red teams, maybe some MNOs, some regulators in the audience can learn a little bit about how we do, and maybe can be helpful for you, because definitely this is what is expected. We had Jean-Dominique Nollet, who is the CISO for Total, who was saying it's his word, not mine, but cybersecurity without red team is complete rubbish. And his word again, but I think this is a good idea, and often, more often than not, there is a misunderstanding of what is the discrete necessity of red team comparison to being blasting away with a fuzzer.
Yeah, so it's super important to understand that, because actually when you see a red team engagement, given the super wide attack surface of a telecom operator, it can be used as a prism or as an analysis tool, which enable you to prioritize where to put some security improvement. Because if you look at all what is to be done for telecom operators, the list of security improvement project is without end, but your budget isn't. So what we see is that it's very often sometimes a wake-up call on some unmonitored or unsecured perimeters, but also a wake-up call for some department and tools and teams to communicate within the operator, which we are not so much communicating in the past. And that can be really a uniting kind of tool. We also, to see how penetration testing and red teaming has evolved, we evolved completely from, in the past, a very coercive kind of security service, which was used sometimes to generate a big report to slam on the head of people and say, oh, you did a bad job. Now it's really not that. Now the goal is to go more for a security support system, to say, hey, at the end of the day, there will be vulnerabilities. The question is, how fast do we detect them? How fast we patch them? And are we able to reduce these metrics? And here, this is really what is broad between the political kind of example demonstration of red team up to the penetrations and to scanning or continuous scanning. What is super important here to understand is that nothing is outside the fair game of attack for the attackers, for the APTs. So that means that the more realistic your red team engagement is, the more it will show up what APTs, what hackers, what basically hostile forces are going to use to compromise your network. And what we've seen sometimes is that they use things such as a backup system, such as things we hardly consider as a perimeter. And yet they are a perimeter, they are an attack surface, and we need to have them in our map and in a complete exhaustive map for the operator. So in order to see a typical red team exercise, we are using past exercise of some of the last red team, and we try to merge them in a what we can see, in a compressed view of what we can see. So typically, what we have is usually a compromise from one of the access perimeter, here the radio access perimeter, and a migration toward both the core, the OT core, and at the same time, the IT application, which can host things such as customer data, etc. So here, what we did in some of the latest red team was to come from an engagement where the customer said, well, here is a few sites, physical sites, so that means radio base station sites, which are going to be your entry point, and we want you to compromise these. Is it by radio? Is it by physical? Is it by the transport network? And from there, show us how far you can go inside our network. And the reality in each of the red team engagement was quite sad, because we were able to go very deep and to take ownership of a very big part of the infrastructure. So the typical way it goes is having a kind of typical engagement where we focus on a typical core network equipment such as Huawei, ZTE, Ericsson, Nokia kind of equipment. And they also come always with miscellaneous systems, such as the system controlling the HVAC, that's the air condition, or the system actually responsible for the physical authentication of security tokens. Or, for example, some MISC system which enable to turn on and off some power, so power management, or sometimes patching management. For example, one engagement which was very interesting had automated a kind of patch system where it could help plug cables according to central command from basically a network operation center. So typically in there, it's very often the equipment of the telecom vendor, but also these miscellaneous systems that enable us to have a jump from the core from the RAN to the core, to access some perimeters, some network perimeters, which are way too open. And when we start this, we start really as any attacker would do. We start with the radio side discovery, the physical attack surface, our log secure. We use basically professionals who are dedicated to physical security. And then we combine them in an attack team, which are going to be able to not only see the vulnerable zone, but when it is the best time to attack. And also to start very often, that depends, but sometimes with black box, so that we have zero knowledge about the target infrastructure. But then we are able to show the result as anyone who would attack the system. And sometimes we combine that after with a gray box where the customer gives us some view, so that we not only have the capability to show the depth of being able to compromise a real infrastructure, to actually have a coverage on all the available attack surface, including some we may have not seen in the initial survey. So if you look at a typical engagement here, what was very interesting here is that there was a weak physical security. And the weak physical security means, of course, that you try to attack some systems, some sites, some equipment that are less monitored. So the ones that are remote, the one who have vegetation next to the radio site so that you can physically compromise without being seen. Once there was a person who reacted to our presence, and he came and said, who are you? And we said, oh, we are doing telecom and mobile stuff with this radio site. I said, oh, okay. So he understood we spoke the lingo. He said, oh, you're not here to steal some metal, because many of the problems they had was people coming to the radio site to steal metal plates and basically to resell that on the black market. So we did not fit the kind of profile of the attacker. And yet we're able to seamlessly break in the radio site, because not only there was in some case some physical security problem with the logs that were used, but sometimes the logs were used in a way which was less secure, especially with combination logs with codes, where there's ways to badly use them. And by understanding how the operator works externally, you start to see patterns and you are able to compromise them much easier. Then there was compromise to the inode, so that's a radio access network heart, I would say. So the cabinet, which enable us through both lock picking and then to be able to have access to some part of the network port, to access some debug port, then to be able from the debug port to access actually the gnode itself by default passwords. That's still a problem. And that's why having an exhaustive default password view with tools such as enumeration, IAM, but also a knowledge with a vulnerability knowledge base on what is vulnerable and what is not is super important. Then from there, we went through the IPsec tunnel to compromise some other equipment closer to the core. And then went towards EMS. So EMS is Element Management System, which is part of the OAM network, so Operational Administration and Maintenance Network. And finally, when we had access to these, to some of the equipment within the OAM network, we're able to compromise critical equipment, such as the lawful intercept gateway and management system, some part of the, let's say, network operation center for the telecom equipment that we were compromising, and then towards the central user database of the operators, the HSS, HLR, etc. So the database backend for that.
Philippe, back to the early part of the skill chain on the node Bs. There is a question around the IPsec. So I know the team has mentioned several times that we talk a lot about IPsec, but in the field, we don't see that much of IPsec. But have we ever been able to circumvent potential IPsec protection?
Well, the thing is, most of the time, we are not having a problem with the vulnerability of the IPsec itself and IPsec implementation, for example. So we don't really find a vulnerability inside IPsec itself. Now, sometimes it's how IPsec is used. We see sadly, some operators who don't use IPsec for their remote sites. That's bad. That's flat out bad. But sometimes they use IPsec, but with the same key shared with all the radio sites. So that's also something that is bad. But most of the time, the vulnerabilities that we use are not even linked to that. The vulnerability we used is the fact that using the same IPsec tunnel as being used by the gnode, we're able to reach not only basically the service with either MME or AMF kind of services, so what is exposed from the core, but much more, such as the OAM, the OSS systems So that's the management system. And the management system should be able to reach the G-node bees. But the G-node bees, most of the time, shouldn't be able to connect to all these ports from the OSS systems. And that's where is the fail. The fail is not in IPsec itself. It's how it is used, how the filtering is done for the network classes that are coming from the G-node bees, etc. And it's very interesting because it boils down on the RAN as well as on the core to not using keywords as a security compliant checklist, but how it is used makes a whole different world in the resulting security. And that's really where we compromise, is where the people really paid attention to quality, to the quality of their deployment, so the quality of their filtering, the understanding the good firewall metrics to really understand, are we really needing HTTP2 flows coming from the G-node bees towards the management interface of this EMS or OSS? And that's typically the kind of things that we compromise.
Yeah. And it's a part of a leeway towards Vafa's question on clarifying the geography where we are able to reach our red team objectives, and if there is any homogeneity, uniformity across geographies. The reality on this question is there is very different setups, realities. I wouldn't be able to generalize towards the geography. That would be unfair to the MNOs. That would be unfair to the teams working for them. So, we generally tend to achieve our objectives, but again, how do you achieve, how do you set your objective changes a lot about the answer that we can give you, Vafa. So let's say that the telecom world needs more security.
And super importantly, in the same country, you can see both very secure operator and at the same time operators which are really insecure, with each of them saying they use the same technology. And that's very interesting, is that you use the same vendors, the same technology, one will be super secure and another one will be not secure. And it's really linked to what kind of security add-ons that you can do in terms of enforcing security features that are available on the vendor equipment, but also to be able to basically complement it with security systems. And importantly, when we do missions for regulators where they say, okay, now we need to scan all our national operators because we want to help these operators get more secure, even though the operator itself doesn't have adequate budget. So now we are seeing these regulators who step in and are here to, once again, support the operator. Well, the differences we see between the results sometimes is shocking to them, but it's enlightening because really it gives a really good focus on what we can do without really changing dramatically the budget, but with more focus on some quality of deployment. Now, there was a question a bit earlier that I don't touch in this slide too much, but which is important. When we talk about the RAN, for example, or about the transport network, there's still a physical component that start to kind of disappear from the mindset of people. That means that extracting secrets from the hardware is still something that can be done because there is hardware and this hardware is exposed to attackers. So when we are talking about IPsec and about compromising the IPsec tunnel, yes, there are some stuff that can be done by dumping memory, by being able to read some flash-based storage, which are still dangerous. So I don't want to go too much into that, but if you want to discuss about that more, there's plenty of discussion we can have. So now to go in more detail, I want to give a view on what is the kill chain that we see, which are really killing the security of operators. What's super important here is that you see a few different practical compromise that we've done. So on the left side, the physical attacks that are listed here and the cell site attacks and the 5G RAN attacks, all of these are real problems that we've seen. Now, what is super important is that sometimes, in order to go from the physical to the service to the actual impact on the production. Sometimes there's a lot of left side vulnerabilities which use the same unique vulnerability to compromise the core. And what is super important here is from a C-level perspective, from the CISO perspective, it enables us to say, well, you have a lot of security problem, but if we secure this single vulnerability in the kill chain, then we isolate the security problem of all your infrastructure back into silos, back into individual problems, and that we have a bit of time to deal with. And that's another key aspect to understand from red teaming, is that not only gives you a priority in terms of what is vulnerable, but it gives you a priority on what to fix first so that you have time to deal with all the other security problems, because we know that we broke the kill chain in two because the attacker are still not able to migrate, to do lateral movement, that's the technical term, to other parts, to other perimeter of the operator. This is super important, because if you reduce your attack surface, if you reduce to a few choke points the places where the attacker needs to pivot, then you have a much more time to deal with securing, to do the protect phase in your security improvement projects. I'm trying to preserve time and go. So on this, I'll go fast, but basically exfiltration, sadly, is super easy. And the fast network and the stealth of the technologies that exist enable really easy exfiltration of the data. So once you have a compromise within the operator, sadly, it's super easy for the attacker to exfiltrate a lot of data. One thing in terms of consequences is that what we see is that always we're able to compromise the core from the RAN. And that's sad, but that's basically the reality. There's not a single case where it's not possible. The second thing is that denial of service is hard from a radio perspective. It's easy from a physical network perspective. So that means that the barrier to entry is more to be able to open a cabinet, and from there to conduct network level, not physical, network level DOS attack, which are going to take out a major part of the network. And the targets are DNS, BGP, or other routing such as ISIS, etc. And we see a lot of problems there because it was not tested. Then the problem is some of the perimeter in number 3 is untested, because the operators say, oh, don't touch LIG because it's government related, and the government and regulators say, oh, don't touch LIG because it's part of what is the operator doing. So sometimes in this case, what we see is that the most critical part of the network is also not audited enough because people are scared. In the last things, we see that complexity, such as having under cloud and over cloud with virtualization, with Kubernetes, having a lot of VRFs, having a lot of new technologies which are not really very well known, enable or force the operator to stay a bit too wide open, which in the end is going to enable lateral movement. And that's typically the case when you add to the mix all the legacy technologies that sometimes are less documented. You don't have firewall metrics. You don't know what are the traffic flows coming from these. And people kind of tend to open the network until things work and then leave it like it is, so that you have a more secure testbed than a production network. Interestingly, what we see is that from a lot of vendors here, so that's we could take an example with Ericsson, but that's exactly the same with Huawei, with ZTE, with everyone. We see that some of the vendors have improved their security, but we see a very heterogeneous kind of picture, depending a lot from the default security of the technology they choose. So for example, Kubernetes brought a lot of security, but what we still see as lacking is that the supply chain security and risk management is lacking, because it's the Kubernetes from the times where Six-Star and all these kind of new supply chain focused security were not really yet integrated by default. And this integration by default is super important. Now, the bad side of this cloud native 5G core is that we see a huge attack surface and also not enough hardening, because once again, you kind of fear that your network is going to be unsupported if you do too many change to it. And actually the vendor tells you, no, don't put an EDR agent in there because we didn't test, so we can't guarantee that there's continuous production and reliability of our systems. And sadly, there are still many lame vulnerabilities. The lamest, but most present, is still default password, of course. But then there's plenty of things which are the way the operator deployed these technologies, which are going to be insecure. And once again, two same vendor, two different deployment, but the result in terms of security is going to be vastly different. There's also another part which has some of the security concept of the past, used a lot by traditional IT security systems, tend to have less relevance. A good example is that now, in a Kubernetes cluster, what is important is the tag of the container, of the tag of the network function that is being running, not its IP address, because the IP address basically is shared within the cluster, is going to be rotated because you have your payload working on a different cluster host or cluster worker. So that means that sometimes some traditional IT-oriented security systems are not relevant anymore. Now, what we see also is in terms of these huge attack surface, we see that there's a lot of MISC systems that are being deployed. And that means that you're not only vulnerable in a given picture with a given attack surface, but there's also the time question. The time you'll see variance in your network at different time. And definitely there's a mix there of things which are complete 0 days, etc., which are being used by APTs. So we need to defend against that, which are completely either not known yet, but will be known, will have CVE. But sometimes it's combined with other vulnerabilities which are specific to a vendor, which are specific to, let's say, a web app they develop, or a particular protocol, a network management system, also an insecure component that they are using for their network function. And sometimes always they use a lot of open source. Well, every open source project can be used in a secure way and insecure way. And what we see is with these typically Kubernetes deployment, the way it's deployed is going to affect a lot the security of the resulting cluster. So we see a lot of problem already at the core, and now what is looming and being tested by upcoming deployments is also Kubernetes at the edge side. So quickly on this, don't be fooled by the barrier to entry to pentest, because what we see is that it's easy to say that you know, or easy, well, to say that you know Kubernetes and you know IPsec security, etc. But what we see is the vulnerabilities which are very interesting and very important or impacting are the ones which are very specific to telco. And very often that are related to vulnerabilities within some front end, within some technologies. And that means that if you have a red team which is not familiar with telco, you're going to miss some pretty significant attack surface. And sometimes these attack surface don't show up at all into the tools such as Nmap and scanners and Tenable and all these IT-oriented tools. I'm going to try then to go to the key lessons learned part of this and leave a bit of time for questions even though we had quite on the chat. Any questions that I need to pick up before the chat?
Most of the questions are around recommendations, technical recommendation on, what to do with IPsec tunnels, if we are seeing any Kubernetes, those are rather technical. So yes, there is some question to address. So if we go into the lessons learned quickly, I would say, and then we can try to tackle some of them. We have Elmedi, who is helping also on tackling some technical questions. So I will try to make sense of it. So we'll leave you to conclude in 5 minutes, and then we take 5 minutes for questions and answers.
Okay.
Thanks, Phil.
So what we see typically is, yes, we are too dependent on the vendor security. So that means that this code to spec or security to specification is something where there's a need for the operator to continuously test their network and feedback their pen test or red team information back to the vendor so that we help them secure their default distribution software so that it comes as a more secure default. Now, the problem is that we often see a kind of stagnation where some areas are not looked for security, or where we see compliance be done as a whack-a-mole, where you have a list of security requirements and, okay, mTLS check, even though it's with hard-coded certificate. OAuth2 check, even though if we reuse the same identity for each NF of a given type. Then a backup check, even though the backup mechanism enable real read access to all the backup freely from anyone who have IP access on the internal networks. These are the kind of things we see repeatedly. And these are the kind of things that actually break the security of the operator. Now, what is important is that when you talk with individual owners of each of these individual parts within the network, they say, yes, okay, this is vulnerable, but it shouldn't be seen from the perspective of the radio access network, for example. And then guess what? It is. And that's the difference between pentest and red teaming, is that in pentest, there's always the yes, but answer from the owner of a vertical of a perimeter. With the red teaming, you say, fine, it shouldn't be, but it is accessible. It is vulnerable. We see some bad people on a SS7 or Diameter or GTP coming from roaming. We see some exposure of this HTTP2 interface to enterprise customer. And guess what? That's the internet. So we really see here some big differences. And pentest is super important, but don't stop there. Periodically, at least every 2 years, you should do a red team on your network with a global footprint available as a target. Otherwise, there are going to be some gaps. Now, what is important to understand here is that the problem is not saying, oh, I have 11 vulnerability on the related to the pen test of my 5G core and its NFV enabling infrastructure. That's not the problem. The problem is not having audited the IMS system and being exposed to it and to subscribers and not knowing if it's secure or not. That's the problem. Vulnerabilities are going to happen and they are going to be patched. Of course, we need to make sure we capture 100% of these vulnerabilities, be aware of the 0 days as soon as possible, patch them quicker, but these are metrics we can manage with CISOs. What is super important is not having dark domains or unaudited or gap verticals where nobody looked at. And that's typically the view we provide. We say, hey, very interesting, you do that. But what we've seen is that you seem to have a legacy VSAT service. You seem to have enabled eSIM with a new marketing MVNO. You seem to have shared RAN or more RAN. These are the kind of stuff which typically goes unaudited and where we help in a red team engagement. But of course, if you say, just look at this part, then we look only at this part. And that's the problem, is that there are going to be some vulnerable technologies. The vulnerable technologies, they come in this kind of a bell-shaped curve. You have the current tech, the sexy 5G, new things, and here you'll see some bleeding edge attacks, and we find that repeatedly. And that's typically the pride of our consultant and penetration tester and red teamers. They come up with crazy attacks, and that's great. But a huge mass of the attacks are coming from the legacy tech, from 4G networks, from 3G network, 2G network, but also from support systems, from OEM systems, etc. And that's where these vulnerabilities are going to be really damageable. And we need to migrate from a model of protection to a new one. This new one really is where we tend to understand the two sides of OT security with infrastructure security and subscriber security. And we tend to fix multiple problems at the same time by coming with new technologies. These new technologies, well, very often they are known. It's in terms of protection, in terms of detection, that's typical firewall, monitoring systems, some checkers, some fuzzers, but adapted to the technology that is being used. Now, in terms of root cause, I think I've covered most of that. We can really easily go in depth in these. I see plenty of very interesting questions. So I'll leave time for these interesting questions. I've really mentioned a key root cause, which is to migrate out of this silo ownership. As a security responsible person, you're not in a silo. That means that you really need to focus on the overall architecture, first cover the breadth, and then go in the depth. In terms of conclusion, definitely we can say that not only operators' operational technology is a primary target to APTs, but that we see too little automation. And that this automation in terms of scanning, in terms of plenty of engagement, we need to have automation both for the defense and the offense so that we are able to react and we are able to scan proactively. And we are able to work in a team with plenty of people who have not security in their job title. We see also that the C-level security ownership is still too low. We need to raise that to the operators' awareness. Now it's being sadly done reactively, post-compromise, but we still need to work more proactively and definitely here leverage our people at P1 who can basically give you good ideas on how to raise the problem to the responsible person in the operators. Still, very often the operators' budget are too low, but that's not the main point. The main point is the willingness to act now, to start little, and to act on the result of the initial security projects. And that's more a mindset, an attitude thing than a budget thing. Let's leave a little bit of time for the question. So let's go for that. And thank you very much.
Thank you, Philippe. Definitely very interesting. It shows us in the number of questions. So we've put the email address. There is some question we won't be able to tackle in the level of details that may be needed. If you have specific topics, we'd be happy to have some of our experts help as Mehdi is right now and answer to the debug ports question. One thing that I think is interesting is we talk a lot about containerization and the famous Kubernetes. An interesting question for me is, do you see a lot of weakening of the Kubernetes security defaults in order for the workload to still be able to run?
So yes, but not like a guy disabled the security mechanism. Most of the time, there are some security exposure that comes with design choices that are being made. For example, some specificity of Kubernetes for telecom and mobile is that a single network function is typically needed to talk to the signaling network and to the management network and sometimes to other networks such as database-oriented network, OEM management, basically some different part of the network. So that means that you need to have multiple interfaces to these network function. That's atypical. That's typically what multi-CNIs in a Kubernetes environment will provide, or any kind of CNI. And these basically container network related, let's say, features are going to expose these containers much more. And the resulting security or resulting attack surface or resulting vulnerability is dependent on, did the vendor really understand what it was going to expose? Or did the configuration activated by the operator really, did the people who designed this configuration, did they really understand that it would expose such network function in a much higher way? And typically here you see the NF owner, the network function owner, 5G aware designer, who needs to understand what the Kubernetes cluster manager or DevOps or SRE or system administrator does, which needs to also understand which VRF, which network is accessible from where, which is typically coming from the network and transport and IP network or MPBN team. So that means that sometimes these three people talk at the minimum just to be able to barely do their job. And because they have no time, they need to run to other projects. So we come in very often to say, hey, let's have a project where we have information from these three, and we're able to give a real-time accurate information on what is reachable on the network and what shouldn't be. And that's typically, it's very different from a guy saying, oh yeah, I don't need encryption, let's turn it off. No, most of the time that's not that. Most of the time is, oh, I need to have production, needs to have this network enabled, and the downstream consequence is that some network services are exposed to a wide area of the network, to a lot of addresses which shouldn't be able to reach these network services. That's much more the case. So it's either multi-hop kind of problem or unforeseen consequence of design choices.
All right. I think the topic of design choices is really underlying in the red team topic. We are a bit over time. It's great to have all of you guys challenging us, asking us the great question that really helps us. So please send us, any ideas, wanting, context that you want us to deep dive to share. We, as you've seen in the last few months, we are trying a lot to share what we find, because we believe it's going to help you guys to have better security. So if you have ideas, contact at p1sec.com. We read absolutely everything. If you have contacts, people, whoever that can benefit from what we are talking about, or if you want us to talk about other things, we are here to support all of you. And again, thank you for the great question. Thank you, Vafa. Thank you, Alexander. Thank you, everyone, for all of this. And we'll come back very soon. The next webinar will be on private mobile networks and the security for both MNO and the enterprise, or the enterprise. Another very fun topic. This should come quite quickly. So thanks again. Thank you very much, Philippe, for sharing all of this.
Thank you.
And let's speak soon. Bye-bye, everyone.
Thank you. Bye-bye.